Hey guys, hey, it's Mr. Lindy here, and today we're going to be talking about exponents. And exponents are a simpler way to write a gigantic number. And the inventors of the exponent came up with this special idea to write it because they got tired of writing these huge numbers that are bigger than the millions or anything like that, or something they had to write a big number repeatedly over and over again. They were just tired of it. They needed a shortcut. So as we're writing, I just want to write out some main exponents that we're going to learn. We're going to learn the powers of 10. Exponents can be other numbers, but right now they have a base and then an exponent. So this one says 10 to the 1, which would mean 1 times 10, and that equals 10. Now, the exponents move on. You have 10 to the second power, or 10 squared, like it's said, equals 10 times 10, or it equals 100. And then moving down, oops, sorry, 10 to the third power would be 10 times 10 times 10, which equals 1,000. And you can check these as you go. You can look, and this one is 10 times 10 is 100, and then 100 times 10 equals 1,000. So that's how you check them. You have 10 to the fourth would equal 10 times 10 times 10 times 10, or 10,000. And you can see, instead of writing 10,000 with the one with 4 zeros, all they have to do is write 10 with a little 4 above it. You have 10 to the 5 would equal 10 times 10 times 10 times 10 times 10. And that equals 100,000. And then finally, the last one that I want you to memorize right now, the rest will just come in hand. You'll know it as we learn these ones, is 10 to the 6, which is 10 times 10 times 10 times 10 times 10 times 10. And that equals 1 million. Now, a couple things to notice about this is really cool. A really cool way to think about this is all you have to do is look at the 10 over here. And if I have 10 to the 1, 10 to the first power, all I have to do is say I have a 1. And then how many zeros are after it? It'll tell me there's 1 0 after it. So 10 to the 1 equals 10. So just to try it again, if I have 10 to the second power, you look at it and you say, so you write down 1, because there's a 1 right there. And then you look over here and there's a 2, and you write 2 zeros after it. So real simple to know what you're having. Let's give an example over here. I'm going to go to the next page, and if I write 10 to the 8th power, and you're like, I don't know what that is. The first thing you have to do, you write down the 1. Then you look at the exponent. The exponent's 8. Now just write 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3, and you have 100 million. So it's a pretty cool looking thing. Another example, let's try another one just to do it. Let's say 10 to the 11. It's a lot. See, what they did was, I'll show you why they decided to use exponents is, there's your 1, you write it down, you look up, you say that it has 11 zeros after the 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you look at it and you have, so there's your hundreds, thousands, millions, and billions. We're looking at 1 billion. And instead of writing 1 billion, they get to write 10 to the 11th power, which is a lot easier when you're writing a math problem, so you're not getting confused. The exponents come into handy really, really well. Another thing that they like to do in our book is they'll give you a problem like this. 3 times 10 squared, or 10 to the second power, and they'll say, what does it equal? And this is how I solve it. I solve it just like this. I write it down, there's a 3, and then times, and then 10 to the second power, if I look at it, I write down the 1, and then there's 2 zeros after it, right? So now the problem is 3 times 10 squared equals 3 times 100, or the answer is 300. So not very difficult, has a couple little tricks to it, but we'll give a couple more examples and see what you think about it. So another one, let's say we have 5 times 10 to the 6. And that's how they write it sometimes, so they don't have to write really long distances in space or something like that. So, of course, the 5 drops down 5 times. Now we have to find out what 10 to the 6 is. Remember, it's 1, and then you look at the exponent, and you write that many zeros. 1, 2, 3, 4, 5, 6. And if you look at that, that means 5 times a million, or 5 million. And instead of writing 5 million, what they write on the problem, the math problem, is 5 times 10 to the 6. It's a lot easier to write that than 5 million a whole bunch of times. Okay. Other fun ones that you can do, you'll see measuring our galaxy. The Milky Way galaxy is 10 to the 18th power kilometers big. So it is ginormous. So you have to look, and let's just look and see what this is. So if I rewrite this, you know that you have to write the 1 down. I'm going to write it over here so I have space. Then you look up here and you have 18 zeros after it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And there you go. That number right there is the exact distance in kilometers around. If you were to drive around our solar system, that number is how big it is, which is crazy. That's insane. All right, so just a couple more practices just in case you wanted to try it. But if I had 10 and I had it to the 7th power and I said, what does that equal? All you have to do is write down the 1, look at the exponents, and that's how many zeros you write down. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 3. And you're looking at 10 million. Okay, a couple more just for fun, just to practice. Let's say 3 times 10 to the 4. And you say, okay, 3 times, and then 10 to the 4, you put a 1 and 4 zeros. 1, 2, 3, 4. So now we're looking at 3 times 10,000, which is 30,000. Okay, guys. Hope this wasn't too crazy or too hard. We'll go over some more tomorrow. You guys have been working really hard. Have a good night. See ya.